point out to you is that it says find the component form. Does it say find the magnitude of the components? No, it just says component form. Component form can have negatives in it. So let me show you the work that I had done. Possibly. So component form is basically kind of like our xy. It's where our where it terminates at the very end, the last point. It goes from the origin to this point. Where basically our x value, which we label as a, is r times cosine theta, where r is our magnitude that was given, and theta is our direction angle. So a or x value is this. B or y value is r times sine, that same angle. This came down to negative 237. The problem is people are so concerned with magnitudes and making everything positive that a lot of people make this positive. Do not make it positive unless I specifically say I want the magnitude of the components. Magnitude of basically says take the absolute value of your answer. If it just asks for component form has negatives in it. Magnitude of the components, you'd have to take the absolute value of. So be very careful reading it and know when you have to take the absolute value or not. Any questions on this? All right, questions on the homework, particularly if you didn't finish it and you weren't sure what I was saying as I walked by about the adding or subtracting. Does anyone just want to see one from the homework, or are we good? Yeah, Joey.
Can I see
25. So 25 is 5, 0. So our magnitude, maybe I'll just put it as v. That's my magnitude is going to equal the square root of 5 squared plus 0 squared. Doesn't really matter. It's actually just 5 squared, so my magnitude is going to be 5. Which makes sense, because if I would have plotted this to begin with, this vector just ends at 5, 0. So the length has to be 5. That's why the magnitude is 5, because the length is 5. Now to get the directional angle, or our theta. Remember, our directional angle is how far does it rotate away from the origin. How far does this one rotate away from the origin? It doesn't go anywhere. In fact, this one's going to be just 0 degrees. It's kind of one you can't figure out because it doesn't make any triangles. You just have to know that that is 0 degrees. Likewise, if it was on this, it'd be 9 degrees. If it would be way over here, it'd be 180 degrees. Maybe I'll show that with red. So if at any time you're plotting, it's here, that's 90 degrees. Over here would be 180. So any kind of points like that, generally you just can eyeball without doing any math. So, any other problem we just want to see? Yeah?
27.
27. 27 is negative 3, 2. Do you need the magnitude on it? Are we okay with magnitude?
Can we just do that too?
Sure. So my magnitude, remember v just is any old vector. It just basically stands for magnitude of v is going to be the square root of negative 3 squared plus 2 squared, which is going to be 9 plus 4. So it's going to equal the square root of 13. All right. The hard one is usually our directional. And to get our directional, we're going to go ahead and plot it really quick. And it doesn't have to be a perfect plot. We're just kind of estimating where it'd be. It looks like negative 3, 2. Maybe somewhere over here. That might be the point, negative 3, 2. I'm going to make a triangle. Maybe I will, maybe I won't. My snap grid is not being helpful. But in short, this is the point up here, negative 3, 2. Since that point, my triangle is going to be negative 3, 2. It's going to have a base of negative 3. because that's our x value is -3 and our y value is 2, so it's up 2. Now here's the hard part about this. I'm actually looking for this angle theta. That's the angle I want. The only angle I can really get is this little one that isn't theta, but it can help us get theta, because 180 minus this little angle is going to give me that full thing. So I'm just going to take a picture rather than going through the rest of it. So my finished work looks like this, where I said I'm going to use tangent, which is 2 over -3, and I said theta equals tangent inverse. I really should use alpha on here. Sometimes I do things quick, which equals -33.7. But I know that this angle here is not, this angle here is actually what I'm looking for. That isn't -33.7 degrees, so I'm going to do 180 minus 33.7 to give me 146.3 degrees is actually the theta that I'm looking for. Does that help? Okay. Other questions, real quick? Okay, we're going to do another example of these in class, so we'll see it again. We're going to talk about some operation rules for vectors. In other words, how do I add, how do I subtract vectors, what's scalar multiplication, and what is this crazy thing called a dot product. We're going to start with scalar. Scalar went back to that first day we had the picture of the 2 tugboats, where one tugboat was pulling at like 1,000 pounds, and the other tugboat was 2,000 pounds. It was a scalar multiplication of 2. It increased the force by 2, but it was going in the exact same direction. That's what a scalar product is. With just letters, it's going to look something like this. If I have k times a vector A, k times vector A, which can also be written as k times, well, vector A has the points A sub 1, comma A sub 2. Don't get bogged down in letters. Remember, these are just holding the place of numbers. This could be 3 times 2, 4, whatever. They're just placeholders for numbers. Well, to actually do the scalar multiplication, it's almost like we factor that k into the vector. So this is going to become k times a sub 1, comma k times a sub 2. And that's all we have to do. And we'll see an example down there. Vector sum or difference, we already did it in picture form. That's when we did that tip to tail method on our graphs on our homework, if we did it, where we go to the end of one and we attach the other one onto it. That's addition or subtraction. How it looks without having to draw it is, let's say I'm trying to do vector A plus vector B, and for some reason I didn't want to have to draw it all out. I just wanted to get where that vector is going to terminate. Well, remember, this is the exact same thing as saying, so vector A was actually a sub 1 plus a sub 2, not a sub 1 plus a sub 2. It's just a sub 1 comma a sub 2. I almost went right to the answer, and that's plus b sub 1 comma b sub 2. Well, to do that actual addition, it's kind of like, remember, this is my x and y values. It's just our 2 x values added and our 2 y values added to make a new vector. In other words, a sub 1 plus b sub 1 comma a sub 2 plus b sub 2, and that's my new vector. So once again, I just add my x values and my y values, and it gives me a new x value and a new y value. That is addition, and guess what? Subtraction is the exact same way. So let's say I did a minus b. That's going to be a sub 1 minus b sub 1, comma, a sub 2 minus b sub 2. In other words, just subtract your y values. So when I did a scalar multiplication, I resulted with a new vector. When I added 2 vectors or subtracted 2 vectors, I came up with a brand new vector. Dot product does not result in a vector. Now, dot product, what's going to stand for dot product? Is this going to look like multiplication? It's going to look like a times b. Now, if you remember anything about matrices from last year, it is the fact that you could add a matrix that looks like this to a matrix like this. You could subtract it. You could not multiply this to this because of the difference in row and column length. So it can't be just a straight off multiplication. Instead, what our dot product is going to be is it's going to be a sub 1 times b sub 1 plus a sub 2 times b sub 2. So the result is just going to be one number. It will no longer be a vector, it's just going to be a number. And in fact, we use that number, the only reason we use it is to compare vectors to each other. And we'll touch a... Alright, so one more thing. Scalar multiplication, basically distributing. Adding and subtracting, you just add your x values and your y values and come up with a new vector. Dot product, you should end up with one answer. I would love to see everyone come up with one answer, but some of you are going to try to force this into a vector. You're going to do this multiplication and force it into a vector. Don't do it, it's just a number. Alright, let's see these in practice. So the first one says that take w and subtract z from it. So we're going to start with w and we're going to subtract z. So w is negative 3 minus the first one in z, so it would be negative 3 minus 5, comma, 2 minus the negative 1. So once again, all I did is I took negative 3, subtracted 5 from it, and then for the next part I took 2 and subtracted negative 1 away from it. And that's going to result in negative 8, 3. Is that super hard to do? Should these be really easy questions on the test? I hope so. But it all has to do with how much you practice and how much you study this stuff. How easy this becomes or not. When I put this on a test, I expect it to be done really quickly because it is just adding and subtracting. All right, next one is negative 8 z. Remember, another way we could rewrite this is negative 8 times the actual vector z, which is 5, negative 1. But it kind of is just distributing. So we're just going to bring that negative 8 in. So it's going to be negative 8 times 5, comma, negative 8 times a negative 1. Well, that's just going to equal negative 40, 8. And a lot of these you can do in your head. You don't lose any points. Just make sure you do it correctly if you're doing it in your head. If you're someone that's prone to making little mistakes, like I personally am, I'd probably have this written out, at least something, so I know that you're trying to multiply by 8. And you just didn't think that 8 times 5 equaled 20 or something. Alright, so that's scalar multiplication. Our final one is 3w plus 4z. Using PEMDAS, we'd need to know that multiplication comes before addition. So I need to figure out what 3w is, I need to figure out what 4z is, and then add them. So let's go ahead and do our 3w. And feel free to work ahead of me. So 3w would be 3 times that negative 3, comma, 3 times a 2. So that would be negative 9, 6 for my 3w. 4z would be 4 times whatever my first value is for z, which is 5, comma, 4 times whatever my second value is, my y value, which is negative 1. And that's going to equal 20, negative 4. So I now have 3w and I also have 4z. Now just add those two vectors just like we did. Did we add one yet? Oh, just like we did the subtraction, but this is addition instead. So 3w plus 4z is going to equal our first term of the 3w, which is negative 9, plus 20, comma 6 plus that negative 4, which is going to equal 11, comma 2. Do you have any questions about any one of those steps that I did here? It's all about doing your multiplication first, and then taking your new things and then going ahead and adding them. If you forget to do that, it becomes a complicated problem where you're trying to combine things that you don't know what's going on. So that's 11, 2 is our final answer. Last thing is w times z. Well, it looks like w times z, but it really is just the dot product. And the dot product is going to equal basically the x values multiplied. So that's that negative 3 and that 5. So it's going to be negative 3 times 5 plus our y values being multiplied, which is 2, times a negative 1. Well, that's going to equal negative 15 plus, well, that's actually a negative 2, which is going to come out to being a negative 17. Once again, I just take my 2x values, multiply them. Take my 2y values, multiply them, add those two things together. Our answer should just be one number, not a vector. Remember that. Get that burrowed into your brain. That dot product results in one number, not a vector. All right, any questions on any one of these four? Going once. Going twice. Sold. Okay. Let's get on to this next one. It says find the magnitude and direction angle of the resultant. The only word we haven't learned in that whole sentence is resultant. It's a big fancy word for just add the vectors. All right, resultant just says add the vectors or the sum of your vectors. So anytime it says anything about a resultant, the first thing you need to do is add your two vectors together. There's two ways to add it. One is efficient, one is not efficient. The first method that's not efficient is to do that tail to tip method, especially in this problem. Tail to tip method would tell you, well, basically take this first vector and on the tip of it, add the other one onto it. Now, don't actually do this because this isn't actually how we're going to solve it. But you remember doing that from the homework. And my resultant vector would be something that goes about here. Just remember what that looks like. It's an approximation, so it probably isn't the best to find the magnitude and directional angle on. Instead, to get a more exact answer, what I'm going to first do is I'm going to label the two ones that I already have. And I'm going to label where they terminate. So the one on the left terminates at negative 6, 2. So in fact, that's vector negative 6, 2. The other vector terminates at 3, 6. So that's going to be my vector 3, 6. Now rather than drawing that tail to tip, I'm just going to add the two vectors together, just like we did on the other side. So to actually get my resultant is just going to be take the vector negative 6, comma 2, and add that to 3, 6. Well, that's just going to equal negative 6 plus 3, comma 2 plus 6. So my resultant is in fact 3, negative 3, 8. So that is in fact my resultant. Now to check to make sure it is correct, I'm going to go ahead and plot it. I'm going to plot it over here. So negative 3, 8. I know 8 isn't on here. We can approximate it as being way up there. We can connect this point. This is our negative 3, 8. That looks about exactly where I drew it to begin with, the tail to tip, correct? So tail to tip might be a good way to make sure that you did your addition right, or you did everything correct. Because if this point would have ended up in like the 4th quadrant, I would have known I made a mistake somewhere along the way. So our resultant is negative 3, 8. So in fact, all this question is asking me right now is to find the magnitude and direction angle of negative 3, 8. I always tell you to start with your magnitude because you're more likely to get that one correct. So let's do our magnitude first. Our magnitude is going to be, well, any magnitude. We put absolute value bars around it. So the magnitude of vector negative 3, 8 is going to equal the square root of a squared, which is negative 3 squared, plus b squared, which is 8 squared. Negative 3 squared is 9. 8 squared is 64, so it's going to be the square root of 73, and we're going to stop there. That is going to be my magnitude. Because there's no perfect square that goes into 73, not that I know of. So all we did so far is get a resultant by adding two vectors. And it just says, what's the magnitude of that? We got it, square root of 73. The last thing we need to find is the direction angle. This is the one where people will have a tendency to mess up because they don't take the time to draw it and understand what I'm asking you. So, as always, anytime I'm asked to do a direction angle, I'm going to draw it. I know I have it drawn up there, but I'm going to draw it again down below. So I'm going to draw my x and y axis. And maybe I'll use green to draw my resultant. So this is the guy that was that negative 3, 8. Well, what I'm actually looking for is theta here. I'm looking for theta. That is my direction angle. However, there's no good way to get right to theta. Instead, I'm going to use this little angle here that I created that right triangle with. And since it isn't actually theta, I'm going to go ahead and I'm going to label it alpha. I'm going to say this little section is alpha. So whatever I find is just alpha, it's not theta. Theta sometimes requires work to actually find. My direction angle is theta. For alpha, we're just going to say, well, I know that the tangent of alpha equals my opposite. Well, my opposite of this triangle would actually be 8. Because taking this, 8 is my vertical component, so it goes 8 up, and it goes negative 3 back. So we're going to have tangent alpha equals that 8 over negative 3, which means that alpha equals the tan inverse, or arctan, of negative 8 over 3, which I believe was about 69.4 degrees. Cool. But it should be negative, actually. Negative 69.4 degrees. So that is negative 69.4 degrees. You see that negative out front? If you get a negative, and you did everything correct and drew it just like me, I have the same opposite in this, that negative tells you either you're going to do 180 minus or 360 minus. Well, just looking at it, it must be 180 minus this, right? Does that make sense? That it's 180 minus that little bit would actually give you my theta. So I probably shouldn't have circled it, actually.
180 plus?
Well, it won't be plus.
How does that angle look smaller than?
It just tells you your theta is going to be 180 minus something. So it is just, well, it's plus 6, negative 69.4, but it's just minus 69.4.
Okay.
Because technically every time we're adding to this 180, is either you're adding a negative or you're adding a positive. This one you're adding a negative, so it looks like subtraction.
Okay.
Okay?
For some reason I thought you said we're...
Yeah, I said it in a very horrible way.
Yeah.
This negative shows you that at some point you should have 180 minus a number.
Okay.
Okay, it should be 180 minus a number, so it's 180 minus that 69.4, which is going to be 110.6 degrees. That is, in fact, your final answer. Yeah, I said it in a very bad way. All you know is if you see a negative up here, you should have 180 minus something. And make sure you have it drawn so it makes sense. Because there's a chance that you dropped a negative sign or something, and the last thing you want to do is have 180 plus 69 degrees and have this drawing, because you've been like, that's way too big if I added instead of subtracted. So always have your drawing. It will save you. It will save you little mistakes. In fact, there was an error on the answer key and I didn't catch it because I caught it in my mind and corrected it within my mind, but I didn't have it correct on the sheet. Okay. The last thing we're going to talk about is angle between vectors. So if I have two vectors and there's an angle between them. If I have two vectors and they're non-zero vectors, because zero vectors are boring, it's basically a tugboat that's pushing at 0 miles per hour. What is that tugboat doing if it's pushing 0 miles per hour? Nothing. So if A and B are non-zero vectors and alpha is the angle between them, then we have this nifty formula that looks easy, but I need to explain for just a second. It says that cosine alpha equals A times B. It's not really A times B because, in fact, that's the dot product. The top part is the dot product of our two vectors. So that's just the number on top. You will not have a vector on top. It will be a number because dot product ends with a number. On the bottom, you might say, well, that must be a vector. What do absolute value bars mean in terms of vectors? Joe?
Has to be positive.
Has to be positive. What's the other word for it? Not absolute value. It rhymes with agnitude.
Magnitude.
Magnitude, nice. These are actually multiplying our magnitudes, which would be two positive numbers. So these are our magnitudes, which will also be a number. So this will be, in fact, cosine alpha equals some number. Now, if you look below it, I really care about three key numbers. I care about when cosine alpha equals 1, when cosine alpha equals negative 1, and cosine alpha equals 0. In other words, when this equals 1, when this equals negative 1, or this equals 0, something happens and I know a key piece of information about it. When it equals 1 or negative 1, it's going to be one of these first two things. And both of these point to one key fact. The two lines are parallel. And how do we know they're parallel? Well, if you kind of picture my two hands as my angles. Say this would be a 45-degree angle between the two. I have two vectors. Well, if it was 0 degrees, they'd just be flat. Doesn't mean they have to be touching, they'd just be up or down. 180 degrees would look like this. That's why the first ones are parallel. The third one's going to be perpendicular because it's telling you it's 90 degrees between the two angles. So that third one, if our cosine alpha equals 0, if I took the cosine inverse of 0, it turns out it's actually equal to 90 degrees. But that third one is going to be the one that's actually perpendicular. So when this equals 1 or negative 1, parallel. When this equals 0, it's perpendicular. All right, let's do an example really quick. Find the smallest positive angle between each pair of vectors. There's multiple ways to do this, and there's multiple ways to break it apart. What I usually do is I say, I'm multiplying magnitudes on the bottom. So I'm going to find my magnitudes first, and then plug them into the equation. So I usually start with, hey, find the magnitude. So I'm going to find my magnitudes first. And the magnitude of negative 3 comma 2 is going to be the square root of negative 3 squared plus 2 squared. Negative 3 squared is 9, 2 squared is 4, so that just equals the square root of 13. Now let's find the magnitude of the other one. The magnitude of 4, 5 is going to be the square root of 4 squared plus the square root of 5 squared. That's 16 plus 25, which is going to be the square root of 41. So you kind of think of that as just a little bit of side work. So I'd even cut that off from the problem. I would just say, okay, I found my magnitudes. Now let's actually do our equation. Well, the equation is cosine of alpha. I used alpha, right? Yeah, I used alpha. Okay, cosine alpha is going to equal the dot product on top. I'm not going to do that yet. I'm just going to write it down as negative 3 comma 2. It looks like multiplication. It's just the dot product, though, of 4 comma 5. All over our two magnitude. Whoa. I swear I wrote it. Let me rewrite it on top of it. Is it showing up now? Okay. It looks terrible on mine because I just have it on top of it. All right, so I'm doing the dot product on top. And the bottom is going to be my magnitudes multiplied. So that's square root of 13 times square root of 41. Well, the dot product on top is multiply your x's, your x values. So that's going to be, let me highlight it really quick. That is going to be that negative 3 times that 4. Negative 3 times 4 is going to give me a negative 12. And then we're going to go ahead and do that 2 times that 5, which is going to give you 10, so plus 10. And that's going to be all over square root of 533 or something. Something along those lines. It's mostly calculator work from here. But yeah, square root of 533. Which really is just negative 2 over the square root of 533. But that's not really important. The important thing is this equal to 1, negative 1, or 0? No. So we have to go one step further and take the cosine inverse of both sides. So that's going to give me alpha equals the cosine inverse of negative 2 over square root of 533, and absolutely you'd get your calculator out, and you come up with like 95 degrees, about 95.0 degrees.
Whoops.
Come up with a different answer?
Yeah, I didn't do anything with square roots.
Oh, okay. Yep, we gotta have those square roots because those are our magnitudes.
Yeah.
All right, what I want you to do is go ahead and do the next one. I want you to do the next one, and I want you to be careful about it because I'm telling you right now the next one's either going to be perpendicular or parallel, and I want you to note whether it's perpendicular or parallel. But this is how I actually got the fact that I knew it was jumbled up. Why is that just doing weird stuff right now? I'll try it one more time. I quit. You guys are on your own.
You're a quitter?
Oh yeah. When the going gets tough.
Tough quit.
Oh, is that what happens?
Apparently.
All right. Here's how I got the fact that it was perpendicular. I would have stopped at cosine alpha equals 0, because I would have done that check, and I would have said it's perpendicular. But if you went too far, you would have came up with 90 degrees. 90 degrees means perpendicular. 0, 180 means parallel. There are questions on the test or on the homework that specifically asks, is it parallel, perpendicular, or neither? So realistically, you're just checking, does this equal 1, -1, or 0? Otherwise, you're going to put neither on it. All right, we still have 1 minute. Did any more questions on this in particular? Okay, don't forget, test corrections are due this Friday. We do have a test. I'm borderline not calling it a test, just because it's going to be short, not have a ton of material on it. I will start counting it as a test, so hopefully it can boost some of our grades if we've been struggling.